Cool. All right, so main observation is
began according to plan as they leapt off the bridge while tethered to the cable.
Stand up. Get it. On three, going. On three, jumper. Great. 1, 2, 3, go.
But as the team was about to reach the end of their first arc, the cable snapped, and 4 men and 1 woman plummeted 70 feet at 80 miles per hour, slamming into the water with terrifying force.
Okay, I'm on the outside helmet cam. Kenny, myself, Boy, Sarge. She does the front flip. Here we come, going into full velocity right here. Probably reached about 78 miles an hour, right about here, 78 miles an hour. You'll see the harness disconnect from the cable right there. Didn't see, just disconnect. My arm goes out, and here we come to the water. Pow! Oh, there's a ton of bricks. So look at the splash, like 40 feet. Look at action, though.
All right, so the question is, why did the cable snap?
The front flip. Here we come, going into full velocity right here. Probably reached about 78 miles an hour, right about here, 78 miles an hour.
For whatever the reason, initially I thought they picked the cable with the wrong tolerance. Okay, I mean, these guys are devils. They were going to do it regardless. And it's a risky business, and I thought that these people end up getting the wrong cable. Then, after this guy kept saying 78 miles per hour, 75 to 78 miles per hour, at that point, somehow he knew how fast they were going to go because the cable that they bought is 200 feet in length. 78 miles per hour, he's not saying 80, he's saying 78 miles per hour, which means that I actually knew the amount of tension that they were going to induce on the cable. That also means that they must have gotten the right cable. So, which means that something must have gone wrong.
You'll see the harness disconnect from the cable.
I mean, these guys are taking a calculated risk. These guys are not being stupid.
Right there. Didn't see, just disconnect. My arm goes out, and here we come to the water.
So the question is, how did they know how to pick the cable, and what went wrong?
Pow!
Next question is,
concentrate on that and to go through the loop. Otherwise, it's not going to be possible. So I had to concentrate on that and just calm myself down. I was probably the most calmest that I've been all day. The speed is critical. I need to make sure that I hit the magic number.
What is the magic number that allows you to be able to complete the loop?
To drive through the loop. Otherwise, it's not going to be possible. So I had to concentrate.
Yeah, I mean, certainly you need to know what that magic number is. You can exceed it. Make sure that you're not under that number. Because if you're under that number, you're not going to be able to complete the loop. You could be upside down, and not completing the loop is not very promising.
Right on that, and just concentrate.
And you can't do trial and error. All right, these vehicles are real expensive, and not to mention,
just calm myself down.
Lives are at stake when you do something like this. All right, so you got to make sure that you know what you're doing, which means that you need to know what the number is precisely.
I was probably the most calmest that I've been all day when I was in there and I was driving down and approaching the loop.
Right, so how do you figure out what that magic number is? All right, so the centripetal force is mass times acceleration. So v squared divided by r is going to be your centripetal acceleration. So mass times the centripetal acceleration is going to give you the centripetal force. Well, mathematically, that's what it means. The meaning of the centripetal force is more important. Centripetal force is inner force directed towards the center of a circle. Inside a centrifuge, you will become suspended on the wall. The part of the reason is because your body wants to move in a straight line at constant speed, and what prevents you from going in a straight line at constant speed is the reaction force. Reaction force generated by the surface force. Surface force becomes the normal force in this case. So that's the force which is directed towards the center. So the centripetal force is the normal force in that case. Space shuttle orbiting the Earth. Notice that the force which is directed towards the center is going to be gravity. Car negotiating a curve. I'm talking about this one. Is able to make the turn is because it's experiencing static frictional force. So what happens when you maximize static friction? In terms of kinetic, the car is going to go into a skid. It's going to keep moving in a straight line at constant speed. So that's what happens. So in that case, it's the static frictional force. That's the car on the road. All right. What time is it now? 7:28. Go take a break for 10. Be back within 10. Yeah, guys, let's go.
It is such a tremendous amount of energy, yet the limits within which it must fly are very, very narrow. So you've got something that's powerful, but delicate at the same time.
The propellants that they use on the space shuttle are very, very potent, and it's like a gigantic controlled explosion that lasts for 8 minutes to get you into orbit. The space shuttle main engines are a very incredible device. They generate enough force to levitate 200 cars, and they could hover them stationary in midair. The fuel amount used is tremendous. The turbo pumps that supply fuel to the engines pump enough liquid it could drain a swimming pool in less than 30 seconds.
Space begins at the edge of the Earth's atmosphere, 50 miles straight up. But the shuttle orbits at an altitude of about 180 miles.
We become accustomed to seeing the shuttle up there, seemingly suspended, hardly moving. Yet the astronauts are traveling around the Earth at 18,000 miles an hour. And as they go about their work, they can glance up at 16 sunrises in a single day. Shuttle up there, seemingly suspended.
Okay, so the question is this: how do we know that space shuttle is moving roughly about 17,500 miles per hour?
Hardly moving. Shuttle up there.
According to these guys, it's moving at 18,000 miles per hour, right? So how do we know what the actual speed of it is? Okay, so this is problem number 1 from the handout. You can either look it up, obviously, much rather we do the calculation. So what do we know? What is the speed of the space shuttle? 180 miles from the surface of the Earth. So that's what we're gonna try to figure out. All right, so here's the Earth. Here's the space shuttle. And it's gonna be orbiting the Earth. All right, let's figure out the speed. Okay, so in terms of the terminology, I need to figure out what I want to use. All right, so centripetal force is going to be caused by gravity. Okay, so I want to use the d for the distance to the space shuttle. All right, so d is going to be the distance to the space shuttle. So this is d. D is going to be 180 miles. All right, so the radius of the Earth, RE, it's going to be 6.38 times 10 to the minus 10 to the 6 meters. Okay, this is something you kind of look up. I memorized it a long time ago because I've been using it forever. And that's kind of it. Nothing else is given to us. And so we want to know how fast it's going to move in terms of meters per second to miles per hour. How fast is the space shuttle moving in terms of that? All right, so for us to be able to solve this problem, we need to know the radial distance, which is going to be this distance plus the radius of the Earth. All right, so that's it. Okay, so we need to do the conversion, so this should be expressed in terms of meters. Obviously, this one is meters already. All right, so what else do we need? That's kind of it. All right, so just give me the conversion for this one in terms of meters whenever you're done. All right, so you guys are doing the conversion. Let me start with the problem. All right, so this is circular motion. And so what is the speed? Which means that there's a centripetal force acting on it in this direction. Centripetal force acting on it is going to be gravity. All right, so the centripetal force acting on it will be the same as the gravitational force. All right, so that's my starting point. Centripetal force is the same as the gravitational force. All right, so we know something about the centripetal force. Generic expression for it is going to be mv squared divided by r. And we know something about the gravitational force, so it's going to be capital G. This is going to be the mass of the Earth, the mass of this space shuttle, divided by the square of the distance in between. All right, so these two will be equal to each other, which means that the right-hand sides will be equal to each other. These are going to be equal. So we got mv squared divided by r. And we have capital G, the mass of the Earth, the mass of the space shuttle, divided by the square of the distance. Okay. Chantal, that's 80.46 meters per second doesn't mean anything. So does anybody have the number for this? All right, Chantal, give yourself 5 points for whatever that is. Okay, I need a number for this one whenever you guys get a chance. All right, move forward. So divide both sides by the mass of the space shuttle. Notice that the mass of the space shuttle is going to cancel. All right, so boom, boom, boom. All right, so that stuff is going to cancel. All right, so that's going to leave us with the square of the speed divided by r. So you have capital G, the mass of the Earth, divided by r squared. Okay, cool. I'll get back to that number. All right. Okay, so the next step is just get rid of r. Okay, so these two will cancel. That's an easy way of doing it instead of multiplying both sides by r. It's the same thing. All right, so we got an expression for v squared. And get rid of the square. Okay, so v is going to be capital G, m divided by r. And r is this expression. Okay, so So it's going to be capital G, M. It's going to be capital R plus D. Okay, so this becomes the final expression. All right, so this is our final formula. Into this formula, we will plug the numbers. So the numbers will go into this formula. All right, so what do we have? We got 6.67 times 10 minus 11. Mass of the Earth is, what is it? Okay, mass of the Earth. Something we have to look up. Oh, damn, it's 5 point. Ooh, this is 6.38. 5.98, I think. Times 10 to the 20. 5 point what?
Yeah, 5.98 times 10 to the 24th.
Okay, very good. Give yourself 5 points for the verification. 5.98 times 10 to the 24th. And the radius that we're looking at is, okay, who came up with that number for this one? Anybody? Okay, so let me just check the numbers on these. All right, so this radius is 180 miles. Okay, Lucy, this 180 miles is 289,620, right? Meters. All right, so give yourself 5 points for that one. Okay, let's get the value for this one. Going once, going twice. All right.
I think it's 10.27 times 10 to the 10th.
Okay, 10.27 times 10 to the 10th. 10.2. Okay, I think that's a little bit too much. Okay, hold on. I don't like it. All right, so these are going to be this. Okay, so we got that. Whatever the numbers are. Okay, mathematically, this is what we came up with. All right, does anybody have a real number for this one? Okay, because the value that I have from here is an approximate number. It's going to be 17,000. Okay, oh, cool. Okay, so Lucia got something. All right, let's use this one. This is going to be 6,669,620. Okay, this seems like the right number. All right, so let's use that number. It's going to be 666. All right, we got 962. 9620.
It's on the PowerPoint side, not the worksheet.
Okay, and cool. Thank you for letting me know. Okay, so all right, so now give me the number in terms of meters per second. Because the PowerPoint is an approximation. All right, so take your time, take all the time you need. Just give me a number.
I got 7,551.
7,551 meters per second. Seems like that's probably the right answer. All right, in terms of miles per hour, just multiply that. Yeah, all right, multiply that by 2.24. Okay, Lucy, your number. Every single person who came up with a number, give yourself 5 points. All right, so this multiplied by 2.24, what do you got?
About 17,000 miles an hour.
It's a little bit over 17,000 miles per hour, right? Okay, what's the exact number that you got?
I got 16,915.
Okay, that's weird because it should be around 17,200 something. All right, so this is around 17,500 miles per hour. Okay, I wonder why the numbers just didn't quite. Okay, whatever. Oh, okay, Elizabeth, give yourself 5 points for that one. Elizabeth.